In this video, we're going to learn how to solve problems involving conservation of energy for your JAMB Physics. So we're going to practice with 8 repeated questions for this topic. Let's get started. The first question here says a carpenter on top of a roof 20-meter high dropped a hammer of mass 1.5 kg and it fell freely to the ground. The kinetic energy of the hammer just before hitting the ground is what? So we are given the acceleration due to gravity, g to be 10 meters per second square. Alright, so guys, take note that the kinetic energy of the hammer just before hitting the ground will equal to its potential energy. Alright, we know that the formula for potential energy is mgh. So in this question we have our mass to be 1.5 kg, we have our height h to be 20 meter, and our acceleration due to gravity g is 10 meter per second square. So when you plug in these values in this expression, we need to have 1.5 times 10 times 20. So let's punch everything on the calculator. That will give us the answer. It's as easy as this. So we have 20 times 10 times 1.5. So we have the output to be what? 300 joules. So that's the option. This question, option C. Let's wipe this and solve the next repeated question. Alright, so the next repeated question will be this question. It says an object is moving with a velocity of 5 meters per second. At what height must a similar body be situated to have a potential energy equal in value with the kinetic energy of the moving body? Okay, for this particular question, we need to establish a fact, the relationship between kinetic energy and potential energy. If we have half mv squared for kinetic energy equals mgh. Now let's find a relationship. This m will cancel this m. Alright, so you're left with, basically you're left with v squared over 2 equals gh. When you cross multiply, you're going to have v squared equals 2gh. If you make v solid formula, you square root both sides. So your v equals square root of 2gh. So in this question, we have the velocity to be 5 meters per second, and we are asked at what height must a similar body be situated to have a potential energy equal in value with the kinetic energy of the moving body. So from this relationship we have here, we are looking for the height. Okay, so it will be, our v is 5, so we have 5 equals square root of 2 times our acceleration due to gravity is 10, which is constant, and we have our height to be unknown. Let's call it x times x. Okay, now we want to make x the square formula, which is our height. Alright, so you're going to square both sides. So when you square both sides, this square cancels the square root. So square of 5, we have 25, right, equals 2 times 10. We have 25 equals 20. 2 times 10 is 20 x. Okay, so you divide both sides by 20. So our x, which is our height, will be 25 divided by 20. Let's punch this on a calculator. It's going to give us, let's check, 25 divide 20. It should be 1.3 thereabouts to be the answer. So we have 1.25. Alright, so when you approximate to the 1 decimal place, it will give 1.3. Alright, we approximate this part to 2, it will be 1.3 meter. So the correct option in this question is what? Option B, 1.3 meter. It's as simple as this. Let's wipe this and solve the next repeated question. Alright, so the next repeated question will be this question. It says when a charge moves through an electronic circuit in the direction of an electric force, it A loses potential energy and gains kinetic energy. No. Yeah, I think this should be correct. Let's take option B. Gains potential energy and loses kinetic energy. No. Gains potential energy and kinetic energy. No. Loses both potential and kinetic energy. No. The correct option in this question is option A. It will lose potential energy and gain kinetic energy. Alright, so that's the correct option in this question. Next repeated question with this question, it says an object of mass 20 kg is released from a height of 10 meters above the ground level. The kinetic energy of the object just before it hits the ground is what? So from the first question we solved, the kinetic energy of the object just before it hits the ground will be equal to the potential energy mgh. So from the question, our mass is 20 times our height is 10 times acceleration due to gravity, which is 10. So when we multiply everything together, we're going to have 2000 joules. The correct option to this question is option B, 2000 joules. That's it for this question. Let's go to the next repeated question. So it says, if a body of mass 5 kg is thrown vertically upwards with velocity u, initial velocity actually, at what height will the potential energy equal to a kinetic energy? So from these expressions we have here, the correct expression will be option A. Alright, u squared over 2g. So guys, take note of this particular question as well. The correct option is option A, in case it happens to be repeated for you in your JAMB Physics. So let's go to the next repeated question, which is this. An object of mass 50 kg released from a height of 2 meters. Find the kinetic energy just before it hits the ground. So if you observe, you notice that we have seen this kind of question oftentimes in this video. So take note of this pattern of question on the right solutions apply. So the kinetic energy just before it strikes the ground will be equal to the potential energy mgh. So the question, our mass is 50 kg times acceleration due to gravity, which is 10 times our height is 2. So 50 times 10 will give 500. 500 times 2 will give you 1000 joules. The correct option is what? Option A. It's as simple as this. Okay, so let's go to the next repeated question. So this is the next repeated question. Now guys, before you attend this question, if you are new to our channel, ensure that you are subscribed to this channel for more of our videos. Really appreciate this. So this question says, having done that, this question says a stone of mass 1 kg is dropped from a height of 10 meters above the ground and falls freely under gravity. Its kinetic energy 5 meters above the ground is then equal to what? Half its initial potential. Its kinetic energy on the ground, C is initial potential energy, D twice its initial potential. So the correct option in this question will be option A. Its kinetic energy 5 meters above the ground will be equal to half its initial potential energy. Alright, half its initial potential energy. So that's it for this particular question. Lastly, for equality class, let's look at this. It says a body of mass 1000 kg is released from a height of 10 meters above the ground. Determine its kinetic energy just before it strikes the ground. Alright, so the kinetic energy just before it strikes the ground will be equal to the potential energy mgh. So for the question, mass is 1000 kg times acceleration to gravity, which is 10, times our height is 10. So when you multiply everything together, you are going to have 100,000. Okay, so 100,000, if we apply your standard form, is equivalent to 1 times 10 to the power 5. Okay, so that's 100,000 for you. 1.0, okay, this 1.0 times 10 to the power 5, which is the same thing as 10 to the power 5. 1 times 10 to the power 5 something as 10 to the power 5. So the correct option in this question is what? Option B, 10 to the power 5 joules. So that's it for this video. Hope there's something interesting from the video. Let's call the video, guys. If you are new to our channel once more, ensure that you subscribe to this channel for more of our videos. Also like, share, and comment on this video. Then I share for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to the question and comment section below, and I'll ensure to give you a response. Also, ensure that you are part of our channel membership by clicking on the join button to become part of our channel membership. In our channel membership, we share special information to those that are part of it that goes a long way to help them to excel in their academic work and in the external exams. Alright, so click on the join button and be part of it, and you'll be glad you did. Now click on the screen above, and I see you in the next video. Thanks for watching.